Today I talk about RAID, what it is, how it works, and is it worth using? This is TQA Weekly. I'm your host, Steve Smith, aka Z-Axis, and yes, you may call me that. We are the 97th episode of TQA Weekly, so season 2, episode 47. And if you have any ideas for the 100th episode of TQA Weekly, send them over to ask@tqaweekly.com. This is the same place you send me your questions, comments, suggestions, and or stories. And we are going to be talking about RAID, short for Redundant Array of Independent Drives, which is also a cluster of hard drives networked together to enhance data security, drive speed, and or expand the total space of one virtual drive. Before I get into the really confusing stuff without explaining anything, I'm going to explain 4 features that are available within RAID. So the first one we're going to talk about is Parity. Parity is error checking code. The simplest is Parity bit, and this basically allows the RAIDs to be able to detect if there's any error within the code while rebuilding or basically checking the hard drives for the quality and or stability of the data. Fault tolerance refers to the number of drives or hard drives that could fail without having a hard failure of the RAID array. Striping is the logical separation of sequential data such as files onto multiple hard drives within a RAID array, and mirroring is the replication of data, also known as cloning, of data onto 2 or more hard drives, so what holds true for one will always hold true for the other. So let's talk about 7 of the most common individual RAID types. We have RAID 0, which requires 2 hard drives, stripes the data onto 2 hard drives, much like putting all the zeros onto one drive and ones on the other, and offers speed, but no error checking, no data security, nothing like that. RAID 1 requires 2 hard drives as well, has mirroring or data replication. It is effective safety net for your data, but has no way of determining parity or if the file or bits are actually in okay state. RAID 2 requires 3 hard drives, has bit level striping, and is capable of recovering one lost hard drive. RAID 3 requires 3 hard drives and has byte level striping with dedicated parity. This is the first time that you see parity and has a fault tolerance of also 1 hard drive. RAID 4 has a minimum requirement of 3 hard drives, has block level striping with dedicated priority, and has a fault tolerance of only 1 hard drive. RAID 5 has 3 hard drive minimum, has block level striping with distributed parity, and has a fault tolerance of 1 hard drive. Distributed parity refers to the fact that the error checking code is distributed amongst the hard drives within the array. So that is RAID 5. RAID 6, also the most expensive to actually put in because it requires 4 hard drive, has block level striping with double distributed parity, and has a fault tolerance of not 1 but 2 hard drives before hard failure. So that means that all of the parity checking code is doubled, so cloned, mirrored. It also has block level striping, which is bigger amounts of data being copied onto each of the drives. And as a consequence of that, and the fact that it has more space to store the data in backup, it can actually fail at 2 hard drives as long as the 2 drives that fail do not contain the same data to rebuild a drive. So that is always important to understand. If at any point any of these hard drives containing the data were to fail while being rebuilt, they fail out. Basically, they have hard failure. So how does one protect a RAID array? So considering that most of the time hard drives don't fail 1 at a time, they may fail out multiple at a time, the only real way to protect your hard drives is to treat them with care. So one of the biggest things that you should actually remember is if you're building a RAID array to have data security, you should start with the best possible pieces. Your hard drive should be enterprise level. You should be using a high quality power supply, and depending on the number of drives, having multiple rails within this power supply. Having multiple rails means better distribution of power. The power output from the power supply has to be constant. If it fluctuates, the environment of the hard drives basically becomes unstable, and you can have hard failure of your RAID array. But this is not enough. Having a high quality power supply and having high quality hard drives will not protect you from a read-write error causing hard failure. So basically having the data screw over your RAID as opposed to having the hardware fail. So you also need to think about having an uninterruptible power supply. My suggestion is APC, American Power Conversion. They deal with personal computers, enterprise level servers, and everything in between. So if you have a RAID array and your actual intention is to provide a safe area for data, running RAID 6 with a high quality power supply, with high quality enterprise level hard drives, and running a uninterruptible power supply is how you will protect your data. So protecting the RAID array is how you protect your data. What is better, software or hardware RAID? Well, very simply, the majority of the consumers out there do not understand RAID whatsoever. You can take advantage of RAID by buying yourself a network attached server that you connect to your network. This will allow you to have a RAID but not have to understand anything about RAID. And the good thing about this is that it tells you which drive is bad, tells you which one to replace, you change it, and that whole setup does the rest by itself. You will also have computer and server based RAIDs that could be software or hardware typed. Now, if you're going to be using a software, I seriously suggest you read the manual. Not all software RAIDs allow for the ability to recover lost drives. So, first, before going into the area of software RAID, read the manual and read how you will recover your drives. If there's an easy to follow way, or at least a way to recover that hard drive, then you may look at using this software RAID. If you are using your BIOS to host your RAID, I seriously suggest that you put all the updates to your BIOS before building your RAID. If you flash your BIOS at any point after creating your RAID, you will erase your RAID setup, basically erasing all your hard drives. There will be no way to back it up. So before you do anything, upgrade everything, back up everything, then build your array, especially if it's software based. Destroying any of the data about your RAID array gets rid of your RAID array, period. So the last thing I should look at is, should I build a RAID for my computer? And this will be 3 answers. What are you trying to do? If it's data security and you will have backups and are willing to follow the instructions and able to recover a lost drive, if necessary, yes. If you're trying to have a gain in speed and are willing to spend hundreds of dollars on drives and are willing to follow the instructions to recover a lost drive, if necessary, maybe. If you want a speed increase, don't understand anything about RAID, and all you have is money and the wanting of speed, SSD, not RAID, is what you should go for. Because a RAID will only give you a certain amount of speed increase, and if you don't understand how to rebuild it, you're going to have to rebuild everything in your computer. So you might as well go with a dedicated SSD drive instead. And here's a really cool thing that you should actually understand. Do you really need to use traditional hard drives in your RAID? So before you start building your RAID out, are you required to use traditional hard drives to make a RAID? And the answer is no. All you have to do is use 2 or more identical hard drives in your RAID array with the same amount of space. That way you don't have the lowest hard drive determining the space for the whole RAID. That way you can get, at least if you're using SSD, a better increase of speed, and on top of that, less heat in your computer and more reliable data. And remember, if using SSD in your RAID, do not allow virtual memory in your Windows session or any other session whatsoever. Next week, I'll be getting into the topic of the sublayer of your website. So basically, those sitemaps and robot.txt files, I'll explain what they do, how to create them, how to use them, basically everything you need to know on how to get your website optimized for search engines. Remember to like this episode if you're interested in today's topic, share if you think someone else could benefit from this topic, and subscribe if you want to learn more. For the show notes of this episode and others, for more information on other ways to subscribe to the show and our weekly newsletter, and how to participate by submitting your questions, comments, suggestions, or stories, head over to TQAweekly.com. If you want to send me directly any of your questions, comments, suggestions, or stories, you can always send them. Email them to me at ask@tqaweekly.com. Stay safe and online, and have a great day. Goodbye.